Exercise 12.3, question numbers 13 to 16. 13th question. In figure, a square OABC is given, inscribed in a quadrant OPBQ, which is inscribed in the quadrant, this quadrant. What you have to find is, find the area of the shaded region. Area of these two shaded region is equal to, what do you have to do? We have to consider this full quadrant and eliminate this area of the square from that. You have to take out the area of the square from the area of the quadrant. So, area of the quadrant, what we have to find? For getting area of the quadrant, what we need is the radius. So, radius means from here to here or from here to here. That is not given. What is given? OA is given as 20. OA is given as 20 centimeter. That means the length of the square is given as 20 centimeter. We have to find the radius of the quadrant. So, this is 20 and this is 20. What about this? This is a right triangle. So, OB square is equal to OA square plus AB square. OB square is equal to OA square plus AB square because this is 90 degree. So, which is equal to root of 20 square plus 20 square, which is equal to root of 800, which is equal to 20 root 2. So, we got the radius of the quadrant as 20 root 2. So, what do you have to find? Required area is equal to area of the quadrant minus area of the square. So, what is the area of the quadrant? Theta by 360 into pi r square. So, what is theta here? 90 by 360 into 22 by 7 into, what is r here? 20 root 2. OB is 20 root 2 into 20 root 2 minus area of the square 20 into 20. So, what we can do is 90 into 22 into 20 into 20, root 2 into root 2 is 2, divided by, you can cancel 360 and 90, 4 into 7 minus 400, which is equal to 228 centimeter square. Here radius of the quadrant is not given, so we have to find that using Pythagoras theorem because this is 90 degree. Then next 14th question, which I am giving as homework. Here what is given as AB and CD are respectively two arcs of concentric circles of radii 21 centimeter and 7 centimeter. What you have to find is, and it is given that the center of this angle is 30 degree. Find the area of the shaded region. Area of the shaded region is equal to area of full sector minus area of the small sector. Area of the bigger sector minus area of the smaller sector, which is equal to theta by 360 into pi r1 square minus theta by 360 into pi r2 square. So, first we have to take 21 as r1. So, theta is 30 by 360 into pi into 21 square minus 30 by 360 into pi into 7 square, which you can do as homework. Then 15th question. ABC is a quadrant of a circle. ABC is a quadrant of a circle of radius 14 centimeter. Here the radius is given as 14 centimeter. This is 14 centimeter. This is also 14 centimeter. So, what is given? And a semicircle is drawn with BC as diameter. Taking BC as a diameter, a semicircle is drawn. What you have to find? Find the area of the shaded region. Area of the shaded region is equal to, what you can do? Area of the semicircle minus, this is actually not sector, this is segment. Area of the segment. So, for finding the area of the semicircle, we need the radius. This is the diameter. So, we can find that using Pythagoras theorem, root of 14 square plus 14 square, which is equal to 14 root 2. So, radius, the radius is half of this is equal to 7 root 2 centimeter. Therefore, area of the semicircle is equal to 1 by 2 into 22 by 7 into 7 root 2 into 7 root 2, which is equal to 154 centimeters square. Then what do you have to find? We have to find area of the segment. How can you find area of the segment? It is actually area of the sector minus area of this triangle. Area of this full sector minus area of this triangle will give area of this part, or area of the segment is equal to area of the sector minus area of the triangle. So, area of the sector, radius is given and theta is given as 90 because it is a quadrant of a circle. So, theta by 360 into 22 by 7 into 14 into 14. And area of the triangle, what kind of triangle is this? This is a right triangle. So, we can use half BH. What is B? B is 14 and H is 14. So, that is equal to half into 14 into 14, which is equal to 56 centimeters square. So, the required area, area of the semicircle is equal minus area of the segment is equal to 154 minus 56, which is equal to 98 centimeters square. So, the final answer is, therefore, the required area is equal to 96 centimeter square. Last question from this exercise. Calculate the area of the design region. Calculate the area of the design region in the figure common between the two quadrants of circles of radius 8 centimeter. They have given two quadrants. One is this is the first quadrant and this is another quadrant. So, the intersection of these two will give this part. So, how can you find the area, one part of this? This one part you can find by taking the sector minus area of the triangle, area of the sector minus area of the triangle. So, 2 times we have to, because 2 parts are there, one is this and other is this. So, 2 times area of the sector minus area of the triangle will give the required area. So, the required area is equal to 2 into theta by 360 into pi r square. So, 2 into theta by 360 into pi r square minus half BH. So, B and H are same because this is 90 degree. So, 2 into 90 by 360 into 22 by 7 into 8 into 8 minus half into 8 into 8, which you can write as 2 into 4 times. So, 22 into 8 into 8 divided by 4 into 7 minus 4 into 8, which is equal to 2 into, you can cancel 1. So, 44 into 8 divided by 7 minus 32, which answer is 36.8 centimeter. This is the answer, 36.8 centimeter.